I'm planning to import nearly all of my Slack messages, messages on Google, and a whole bunch of other memories, and try to get that running with my OpenClaw locally. And there's an interesting twist here is that I have access to a DGX Spark thanks to NVIDIA, and I'm going to try to see if I can figure out how I can get some local models running on that little Spark device. So that way I can have all of my data from all my conversations, including transcriptions from meetings and pretty much every other types of interaction, indexed and searchable. The current limitation that I have is that everything has to be in a markdown file, but when you have meetings, when you have other types of things like emails and other type of stuff, you're going to have to search for different systems. And these systems can cost 20 bucks a month, upwards to 4, 5, even thousands a month if you want to try to do this through cloud services. And I thought this would be a good time to try to see if I can learn and play around with these systems. And I basically have taken the time to kind of map out what this would look like for us. So that way I can try to get this set up. So if you have some local hardware, even like a local PC with an NVIDIA graphics card, like the 4090 and stuff like that, you should be able to, or 5090, or stuff with the Blackwell systems, we should be able to apply some of these principles so that we can kind of get this going. So this is kind of the high level overview of what things are looking like. I have stuff inside of Notion docs through my business. I have other editors and different people who interact with those workflows. I have Slack messages. I also have meetings and stuff that are recorded. I have stuff in Google Drive and also Markdown notes. And what I want to do is I want to have my OpenClaw be able to ask, my OpenClaw is currently running on my Mac Mini. I want it to be able to ask my system, and this is going to be called the contextual memory layer. Everything's going to be stored here in the database, and it should be able to understand and comprehend the data. And it's going to basically be able to reason through all the way through with like a local model, and it should be able to tell us what type of answer we're getting. So this is going to be a really cool way to utilize local models. We have finally crossed a chasm where local models are finally good enough to do these types of workflows locally on device. And what's nice about it is that we own all the data. I've exported all of my ChatGPT chats, also my chats in Anthropic, and now I'm getting ready to pour a whole bunch more data inside so that I can start to reason about it and try to actually, find out interesting things and help me run my business a lot smoother and so forth. So I know a lot of people are interested in this topic, and I think this is going to be a really good, we're going to do a lot of like technical breakdowns. We're going to kind of deep dive onto this. This is going to be like a multi-day series as well. And this is not sponsored by NVIDIA. They did send me this device. I've been really curious and wanting to tinker on this device so much. And I thought this is a really good exercise in trying to figure out what does this landscape look like. You're going to see my thinking through these things. You're going to see some of my research. Also, if you're a member of the Discord, I actually will have these links in the Discord so you can actually download them and you can actually see these overviews. So I have a couple different breakdowns that I'm going to go over. And this, you can just literally just scroll through this whole thing. So yeah, just kind of going overview as far as how this is going to work again. This is layer 1. This is where our data lives, and it's going to go through layer 2. So the couple of models that we're looking at is going to be the Whisper model for the voice to text thing, and then we're going to use NV-embed v2, which is going to convert the text into meaning vectors for search. So this is going to be super useful, and these vectors are going to be stored in a QDRANT database, quadrant. And this is basically whenever you ask for something like what was said, it tries to find similar content by the meaning. So this is going to be super helpful for us. And then we're also going to have another layer 2 that's in here that's called GLINER, and this finds people, projects, decisions, dates, and action items. So now this data that's coming in is going to start to be grouped by this. And so it'll tag people, projects, and decisions, and that's going to be done through the Falcor database. This is going to be like, yeah, who, what, when, and then going to try to like map these different relationships and entities. All of this is going to be running locally, by the way. All of this is going to be running on the Spark, which is going to be amazing. So we'll have this data that's going to be processed in here in our layer 3. So that's how the data is going to be stored in those ways. And then we're going to send it over to an LLM. So the LLM that we're going to use on device that's going to be running on the Spark is going to be the Qwen 3 30 billion. And so this will basically be able to read and retrieve the context and should be able to give us a grounded answer. All of this basically is running on the Spark, which is only 128 gigabytes of shared memory, fully local. And this is going to be an amazing work through if we get this full thing working. I think it would unlock a lot of people who are already spending 500 to like $1,000 a month on these different services. If anyone has used any one of these types of things, when you start to scale up, it gets pretty hairy pretty fast. But with this type of breakthrough, we should be pretty good. This was all inspired, by the way. Sorry for the flashbang. I know it's kind of bright for me too. Um, Let me see if I can change this to dark mode to help with people with, yay, okay, cool. In here, this was actually inspired from a talk that I saw on YouTube, and this is from Pulse HQ. So these guys basically were doing a talk on YouTube, and they talked about this type of system, and what they mapped out was they have all these conversations, CRMs, meetings, and so forth. So they use these in call centers because that's how they're able to map and do all this type of data. And so they ingest and process real-time call transcriptions. So whenever someone joins live, they're able to do document parsing and chunking, and they're able to do like entity extraction, exactly what we're doing, and also the relationship mapping. And then they basically create a context graph from that. And then from there, they hand it over to the agent layer, which helps them with case report, triage recommendations, and fix from like historical context. So if you can imagine this type of thing, if this device is powerful enough to do this stuff in real time, can you imagine like putting one of these types of things in a call center in your businesses, or also scaling it up? This is what's cool, and this is what I'm going to try with my local, everything's going to be local, and it's really cool because now I have an OpenClaw instance that will just hit my own data points and then be able to pull this stuff in. And if I have any meetings that are running with transcriptions, I should be able to transcribe them in real time. I should be able to pull these relationships, and then probably in real time during my meetings, kind of do this really cool stuff. So I'm pretty excited for this type of thing, and just kind of want to catch up a little bit on the comments. And I know a lot of people have a lot of different things that they're talking about stuff. I also have the kind of comments featured below, so if anyone's doing some funny stuff, you will get banned. The DGX Spark's cool, but we need a comparison with the Mac Studio and M3 Ultra. So I don't have an M3 Ultra yet, but if Apple decides to send me one, I'm more than happy to do that. I was too late to buy it, and I don't know if you've seen the prices right now. Check this out. Let's go to apple.com. You're going to be surprised how long it's going to take to get one right now. So check this out. We go to Mac. We're going to go Mac Studio. This is like, I have a Spark with me right now. It's actually in my house. And we're going to config a maxed out M3 Ultra with 512 gigabytes of RAM. Right now, the wait time is 11 to 12 weeks, and the pickup is going to be by May 26th. So we're going to wait till May 26th. This is February 21st. Almost like we're not even like changing anything. We just literally just did the maxed out one. We haven't even selected the actual hard drive space. That's already 11 to 12 weeks. So by the time I get one, if I get one, it's not going to get here in time. So yeah, if Apple decides to send me one, I'm more than happy to take a look at the M3 Ultra. I have a 128 gigabyte RAM laptop, and basically right now I'm just kind of moving forward with the Spark because that's basically what I got right now. So yeah, Whisper is great for sure. Do you think an 8 billion distilled model will be good enough for the tool calling orchestration? I'm going to play around with this, and I think we're going to try to see what we end up doing here and stuff like that. That's great. I think about getting a Mac Studio. What do you recommend to run a local LM? Sorry, just jumped in. Let's go ahead and try to go through this right now, and then I'll see if I can kind of figure out, if you're just trying to get into it, like if you just got a Mac Studio local model, you could try the Qwen model. If you're just doing some queries and stuff, if you can, just depending on how much RAM you have, I'm going to give you this resource right now. LLM Calc. I made this. Oh, my site is down. Oh, okay. I gotta push this site. Ray Fernando. Okay. Let me go to my GitHub. I have an LLM calculator. My site is down. I gotta republish it. Let's see. But it's open source. LLM-calc. Okay. Wow, I can't believe my site's down. It's okay. This is going to be super helpful. So this inference calculator is down. No. Okay, so I'll have to get this back up again. But you can clone this, and in essence, you can do the calculations for yourself here. And this will be super useful for those who are trying to run that. So yeah. Okay. I'll get this up and running later, but yeah, we're going to take a look at that. Okay, cool. So I need to repost this thing live too. So let me just go ahead and get this going. So right here. So there's a problem with X in which they don't actually post my live streams. So I have to like manually post and stuff. Yeah. And I'm going to attach I don't think it matters. Yeah, I'm just going to do this. OpenClaw. Perfect. Okay. Cool. Yeah, if anyone's on X, please repost it. Looking forward to seeing how the 30B is also, inference B is very tempting to get going. Yes. Yeah. I think right now I'm just going all in on Spark because I have it, And this is like, memory is probably more important of a problem right now than anything, because I want to just have, and I already own my data. It's already sitting on a Mac Mini. I want to throw it over to the Spark and do this indexing, so that way I have all my stuff indexes. So, you know, this is basically what exists today. Every single system like Notion, ChatGPT, Google Search, they all have your data contained in these different places, but you're able to export them out as of right now and own them. And so once you put them into your own layer, then you can do your own stuff like semantic search, knowledge graphs, run local models, keep everything here. So this is kind of where, you know, this is where the current tools are limited. They can't talk to each other. ChatGPT is not going to talk to Anthropic to share projects or anything like that. You know, they're beefing. Notion AI has their stuff in there. You know, like stuff is everywhere, and I really don't like that. And so I want to kind of try to put everything into one container. And this is going to be how we're going to do it. And this is going to be a really cool map out. So I've already had a conversation a lot with Claude. And with Claude, basically, I was able to kind of do this little bit of a breakdown, and we're just going to go through the setup right now. And so the way that things are going to look like is I think we have to set up some Docker containers to basically set up the actual databases that will actually work for us. And so they'll be running on these different ports along with Whisper. And then we're also going to set up some of the UV environments so that we'll have our different services exposed. And then once we do that, we're going to create some scripts so that way we can have endpoints to hit them, and then they'll do the embeddings and all the different stuff. And so all we have to do is then give OpenClaw a skills file or some type of script to say, whenever you're asking a question, just hit this endpoint. And that endpoint is going to be on my local network. And that local network, in the way that I'm doing it, I'm just going to give this overview here. I have we're going to use the Tailscale. So Tailscale is going to be the one that keeps everything in my container here. So we have a Mac Mini, which is running OpenClaw. It's actually working through an encrypted tunnel through Tailscale VPN. And then it's going to basically access my private network. So within my private network now, we're going to have this here, and it's so slow right now. Okay, sorry. Okay, in here, we're going to have the DGX Spark, and this is going to be where, like what I was telling you, the Docker containers, the virtual environments, and the existing setup I have. So I'm also serving vLLM, GLM 4.7, and this is actually going to my Droid. I may not even use this anymore because I'm just going to use Droid directly with the Fireworks providers. So I'll just focus on my memory up here. So that's kind of like the setup there. And then we can talk about like some of this stuff a little bit later on, so that way I can just start stuff processing. But yeah, this is kind of the network topology. If you can kind of see, these are all the different components, and how stuff works here. So okay, yeah, all this stuff is all mapped out for us. So let's go ahead and start through these things. So I can, okay, interesting use Safari as it's hated by most devs. Dude, Safari is the best browser. I don't know why devs hate it. I think that's a skill issue, bro. Yeah, like if Safari is the best browser, I'll put it up against everything. One, like for power saving, two, for like memory, if you're using it on a Mac for optimizations. Like it's just so embedded into the OS, and like with security and all these other things that like, I don't think people really realize, like, there's like the developer part of it, but there's also the consumer side of it. So on the consumer side of things, most people don't realize how much data they're leaking to the internet, and like how many of these companies are just grabbing information from your device, and they can start to fingerprint you pretty fast. And so like if you ever use Safari and just go into like private browsing mode, it's actually different than Chrome's private browsing mode. It's actually more secure and much more private. And like as far as like identifiers and various stuff, you know, all these companies are trying so hard to hook into your devices. And don't even get me started with like Chrome's tools for like running stuff in the background and running shadow services. And like it gets really kind of crazy from a privacy perspective. And so I prefer to use Safari because I don't like spyware. I mean, I like to, yeah, but that's what's up. That's what's up. Yeah. Shots fired. I know. I could say that because I worked on the operating system, but okay, let's go. They fixed NV4. We are back in business. Okay, did they? I think they did. Cool. So let's go to the setup plan. So I needed to do some stuff. So what I'm gonna do is I have Cursor pulled up, and I've already SSH'd in. So one of the cool things about VS Code or Cursor is that you can SSH in, and then you can run the agent to do stuff for you, which is actually very, very helpful. And so I'm just gonna pull up some of these commands. I'm just gonna double check to see my CUDA versions and everything. So I should be able to do these commands here. Let's see. Awesome. Cool. So I have CUDA 13 with a compiler there, and then NVIDIA SMI. Okay. Perfect. And then I should have Arch 64. Yep. And then how much free memory do I have? Pause. This was directed at me. No, it wasn't, bro. I was the Safari stuff is just I hear this all the time, and I'm not a web developer, and I think that's the other thing. It's just like I'm just yapping because I'm not a web developer, or I don't think like I think people the lines are getting blurred right now. It's just like I'm an engineer. And so I'm always like I always like to cap back at people. Okay, so I think actually let me just show. I don't think I need this. I just can do verify. I think I have memory swap. Expected no output swap is off. Okay, so the swap is on. Oh, so disable swap. I didn't realize this. Okay. Okay, cool. I don't think I have Docker. Oh, I do. Okay, cool. Check the NVIDIA container toolkit. I don't think I have this either. Tail scale status. Okay. Python version. I don't think I have. Oh, okay, cool. UV version. Hey, what's cooking, man? If you don't know what's cooking, we're gonna be going crazy deep. I'll get you caught up in a little bit. I'm just trying to ensure environment variables are set. Echo Triton paths. Okay. Okay. Let me just take a look at some of these paths here for a second. We're gonna go in. Today's like a hack stream. We're literally just hacking away at stuff because we're about to we're basically gonna replace the TLDR right now is that we're gonna replace some services that cost $500 a month. People are trying to charge crazy prices for indexing your own data. We're gonna do this all locally. There's no reason why we can't do this. Okay, cool. Create a project directory. Okay. I've got everything going. Let me just turn off the swap thing though. Okay. Swap it like it's hot. I'm gonna do new agent. Okay. So cool. All right. So if you don't know, for those who are just tuning in right now, if you just got in hot, let me get you caught up real bit. In essence, the long story short is we're gonna create like contextual memory for our Clawbot so that we can have all of my data, because I currently have all my ChatGPT and Anthropic history, but I'm now going to get Notion, Slack messages, Google Drive, all my different stuff from my companies basically going in here. And then I also want to do real-time transcription with meeting notes. So that way we can put them into like a whole memory layer, and we can pull the understanding in real time for like remembering events and making these different relationships and stuff. Because one of the downsides of what we have right now with our system is that it may not run as fast, or we may not be able to leverage a lot of the real-time stuff. So with the DGX Spark and also with NVIDIA's, obviously all of the NVIDIA stuff is just going to be going crazy fast. It's just an endpoint that we could just hit and everything should be like cooking super crazy. So as you can see, all the different data containers like Notion and ChatGPT live in their own entities. Now we just fill them right into our memory layer, and we'll have to basically do everything locally here, which is going to be amazing. And so data will just come in, and then we're going to do a layer 2 type of thing to have our AIs try to understand things. So we'll split them up by GLinear 2. And they'll find people, projects, and decisions. We'll tag them and we'll store them in the Falcor database. And the other ones for like Whisper transcriptions and stuff, it'll convert the text to meanings for the vectors. And then we'll use Quadrant for what was said and trying to find similar meaning. And then we're going to use Qwen 3 locally all on the Spark to basically do the retrieval. So this is not going to cost us anything, and this will just keep running on the device forever. And as our data sets grow, we don't have to pay more or anything like that. We can just do as much as we want. So I want to show you something, and I'm not like saying that this is competitive to this, but I think sometimes whenever there's something like this, it always gets you to say, can I build something? But I'm not building it just to replace it for price. I'm literally trying to understand, how do these systems work? Can I build a similar system? I'm not necessarily doing this to save money. I'm doing this to learn and push myself, because this is not something I normally do. But I feel like the more time that I spend with this, it'll actually pay off dividends later on in the future. And I think if you start to kind of take some of these principles, then you can then apply them to, like, for example, running stuff on a Mac Studio, right? What models can I do to the same thing? So if you're in the Discord, you should have access to these links to be able to kind of look through this. And then you could even hand this off to your agent and say, hey, I only have a Mac Studio, I don't have a Spark. How can I do the same thing? And then you can kind of get a whole plan of action there, which would be super fire. But yeah, what's crazy is, like, after you have 80 million tokens processed, you're paying $4.99 a month. And so for mine, when I did the whole research here, I already have 80 million tokens between all my different messages and stuff, with all my different, I haven't even input Slack or anything else. So let's see if I can see tokens. Okay. Yeah, I have just about 80 million, and that's just between all of my chat history from ChatGPT and Anthropic, and it hasn't even included all, like, my Slack messages, my emails, my Google Drive, and all this different stuff. So I would be basically paying $400 a month just to talk to my data. And I think that's a crime. And this is definitely doable with the device. And yeah, I don't know, like I get this because this is a cloud hosted service, but like I want to own my data and I want everything to be processed locally. And so I feel like, I'm not saying that I'm going to be able to replace them, but I'm going to, like, take a stab at it. And then I'm going to learn a lot, because I don't know, like, there's a bunch of things I just don't know. I'm not an expert in this space, but that's how we're going to learn. We're just going to learn by doing. So that's basically the long story short of it. And this is how we're going to try to achieve it. So I basically pop stuff in for those who are wondering. I have I did a whole report on this as well, for this memory layer based off of Pulse HQ's like YouTube video. And I try to understand how this will actually work for, like, deciding what embedding models will work well for the DGX Spark. So it gave me, like, this type of research list here. I use Exa MCP for helping me do the research, which is extremely helpful. Claude and Exa MCP are just amazingly helpful for research tools. And then this is like the entity extraction stuff. So all of the different models, I ended up with this one up here because of this. It's like probably one of the top as far as like memory efficiency and parameters as well. And then this is like for the reasoning, we have these. So I can also use the GPT open source model or the Qwen one as well. So there's like these different trade-offs that you have for devices. I was going for higher tokens per second. And so I think it was like excellent quality ratio. So it still leaves free for other things. And so this is like basically the first part of the report. I pop it into here and I basically tell it that I'm basically trying to build this, and how should we actually dig in to start to implement this. And this is kind of what it came back with as far as a review. And then told it to like ask me some questions. And this is kind of what came back as far as like, which ones actually have issues and not. And this is the other part of why you use Exa MCP, because it starts to dig through the GitHub issues, and it even pulls into like, hey, wait, there's just a thing that was just released today where they unlocked NVFP4 on DGX Spark, claiming that their custom vLLM image now basically works 20% faster. So it's like, okay, let's go ahead and see if we can try to use that here. And this is kind of where we ended up here with our latest research and implementation plan. So this is going to be the plan I'm going to follow. And if you're just tuning in, this is going to be what we're going to go ahead and do here. So, okay, so basically now I'm going to just give some of this information to Cursor and let the agent do its thing, because all we have to do is now basically start with phase one and start to do this type of database stuff. So let's go ahead and do that. And then let me just turn off the swap stuff. So this is for the unified memory safety. Otherwise my device will hang if I flood the memory thing. So let me do some things real quick. I'm going to change screens so that I can do some of this little Git stuff here, or this sudo swap off passwords. I have all my stuff stored in passwords. Keychain, Spark. Okay. Yeah, I don't have any passwords that are safe. Okay, cool. So then if I run the other swap on show, actually, I think I should be good. Cool. Yay. I have the swap thing turned off. Perfect. Awesome. I got those here. Okay. So Awesome. I think I'm good. I'm gonna go back to here. Awesome. Cool. So I have Opus Max and I have Opus Fast. And I'm going to say, let's go ahead and start with phase one. Okay. Let's go ahead and start with phase one. Okay. And let's go start playing loose. Yeah, so this is kind of part of the architecture is that we already have some of the other stuff that's tagged, and that's what we're going to be using the two different databases, right? So and like I think, let's see, here we go. Where was it? Yeah, I'm gonna start with this suggestion first with Fulker and Qdrant, and then do some actual like, what do you call this? I'm gonna try to see if I can grab some not benchmarks, I guess, yeah, benchmarks and stuff, and see if it's actually working like the way that I think it should work. And if not, then we basically like fix it or add different things. It should be easy to kind of swap stuff in and out. So that's kind of where I'm starting. Would love to hear anyone who has experience in this as well. So that's also very helpful. Wow. They just put your data in a GraphDB and Progress Vector and do some simple tool calling. Well, I mean, I don't know if it's that simple, but like they're also doing some type of invalidation of the data. So they have to, one of the techniques here is if you say, I like Nike shoes, and then all of a sudden you have a new memory where like, wow, these Hokas are amazing. I really like these shoes now. Your LLM has to now say, okay, this is the most up-to-date data for the shoes entity, for those types of relationships that Ray's talking about. Whenever he's talking about his favorite things, we have to look up what that is. That's currently Nike. We're going to say that's false now. And then this other thing is true, for Hoka. So like you have to somehow map those things so that when it comes back up and later on and people ask like, there's all this data that you talked about for Nike. And then since the most recent thing is Hoka, you can say, okay, like he likes Hoka. It's like he likes Hoka sandals, he likes Hoka shoes, but he likes Nike, whatever this is, right? I don't like Nike at all, so it's just like just delete everything Nike. So it's like that's what's up. So I think this is going to be the fun part, and this is kind of where I'm really excited to learn about this, is because I really don't know how these systems really actually work from a like low level technical level. And so by taking on these projects, I'm going to be able to learn and then be able to speak about them a lot better. I mean, like, okay, I know that like if I'll be able to speak better, like, what's the difference between a relational database versus graph versus vector versus RAG? How does re-ranking work? How does like the time sequences work? How do relationships get drawn? And then like what specific models of data work better for certain types of retrieval patterns? And then like what is happening in the actual space? And so for me, and hopefully for you as well, that you'll get to learn by doing, because a lot of people have a lot of different use cases. And for me, OpenClaw is kind of that driver for me. It's like, okay, I have my company's data, I have records, I have meetings, I have, all these other types of things that I'm doing as far as activities. And this is where I'm going to learn to figure out like, okay, whatever I learn, I'm just going to share back with you live. So I think this is the whole purpose here. And hopefully you also can take something away from this as well. And I would encourage you to start looking into your own type of memory projects to help you learn. And, when you have something physical that you're talking to every day, if something's not working. So then you can start to apply some of these types of learnings for yourself. So I think, what do we have going on here? So we created the project directory now. So we have contextual memory. And then we have, let's go ahead. Oh, cool. And then now we have a config. So part of the cool thing is when you SSH into something, having a VS Code instance or cursor, you can see the directories right away. And to me, I really like that type of stuff. Okay. So we're going to create the Docker compose, which we already did. And then we're going to start the infrastructure of the databases. So the Docker version, Docker compose. Okay. And so Docker compose are ready. The project directory doesn't exist. So let me get the full structure, and it set up the services. And so it's now basically doing the compose up here. And it's, okay, so now your user isn't in the Docker group. So the Docker commands are getting denied. So the socket is owned by root Docker, and you'll need to run this command in your terminal. It requires your password. Okay. So now I have to enter my password. Perfect. And so let me go ahead and do this here. Blur screens. Let's go ahead and blur the screens. Okay. I'm so cooked. Okay. And then, cool. After that, Docker commands will work without sudo. You could run, okay. Try now. I'm just going to try this. Unable to get image. The shell system doesn't pick up the new group membership. Okay. Oh, it's doing it now. Perfect. Cool. Epic. All right. So it's going now. Awesome. Perfect. Sounds like a schema design project. It's a whole bunch of stuff right now. Did you set up multiple specialized agents that are persistent agents? Did you get a mission control yet? So no, I haven't got a mission control yet. I'm just keeping it sort of simple with one agent on my little OpenClaw on my Mac Mini. And then the DGX Spark is going to be the actual place that holds the local models plus the graph databases and all the things that we need to process all of our memories so that I can just throw everything on the Spark. And so the Spark is going to be my workhorse at the house, which is going to handle everything. JDX are ASDF useful tools for managing Python node and libraries, and Mize is the ability to run tasks and manage both node and... Oh, that's cool. I haven't really played around with that. I'll have to check it out. Thank you. Would you say your interest in Hoka in a context file, or would you use a transformer model to train your relationships? So that's kind of what I'm trying to figure out here. It's like with these systems, it may look up stuff, and so it may rate certain things higher just because it's much more visible in the data set, and that may not be the thing that we want, right? So there's a combinations of things that we want as far as like how we pull that data up. Redis for in-short memory, and Qwen for long-term memory. Oh, I like this. You probably at least want to pull all of the Docker run commands into a Docker compose. Yeah, I think that's what it's actually doing for me right now. Okay, cool. Yeah, 88 million tokens is not a lot of data. Yeah. All of this running in a Kubernetes. No, this is running on my Mac, on my DGX Spark, actually. Yeah, thanks, man. I appreciate you popping on. This is so cool. It's only 6:38 here in Hawaii, so it's actually kind of early. Okay. Only consider a DGX Spark if you're fine-tuning a kernel dev. I would think so. Yeah, I mean, there's a lot of different kernels you can touch. Surreal QL just popped up in the algorithm after spending at least 6 months building nothing but Swift WASM compilers. It's like 6 months ahead of everyone on AI. I don't know how to stop the thieves. I don't know what this means. Yes. Okay. I'm almost 6 a.m. in Prague. Whoa. Insane, man. Cool. Let's see. Okay, so let's see what phase 2 is all about. So preview for phase 2. So we got pre-flight checks was what we did. We now did this part here. Okay, so we created the Docker Compose for infrastructure. We have all these things here. And then we started the databases. And so now we have to verify these here, which I think it did over here earlier, right? Yeah, it did all the verifications that everything's up now. And then now we're going to go with phase 2, vLLM with NVFP4 reasoning LLM. So set up the vLLM using Avarex NVFP4 enabled image to serve Qwen. And why? This is the brains. This is the LLM that reasons over retrieved context to answer questions. Should be 20 to 40 minutes, mostly download time. So the good thing is that my internet connection is actually in California. So that's where my Spark is right now. And so I have a pretty fast connection there, and it's connected right through gigabit Ethernet. So that should download pretty fast. There are multiple vLLM images for the Spark. We're trying this first because it claims to have working NVFP4 support. If this fails, we'll fall back to Igor's image with AWQ. Fire. Okay, so all we have to do is this Docker pool. This is amazing. Attempt. Okay, let's do phase 2 now. And then check memory before starting, and then need at least 30 gigs available, and then try serving the model. Whoa, this is gonna be crazy. Awesome. Okay. Verify attempt A. Cool. If the attempt A succeeds, skip to phase 2, verify final. Okay, let's try this. Great. Let's move on to phase 2. Let's go. This is awesome. 1 hour for Docker vLLM to compile. Really? For real? On a Spark? I'm curious. You get it's yeah, I mean, it's fire, right? Let's see. Let's see what's going on. So right now we're basically research check the Avarak image. Okay, cool. Pull a Avarak image, download FP4 model, start vLLM serve. I don't know. Let's see. Search the web. Do I have enough free? Yeah, I have enough free. So research looks great. Here's a summary. 115 gigs available. The latest tag is January 24th. All tags seem to point to the same digest. Interesting. The Avarak image is a clear winner. Let me proceed with the attempts pulling. Cool. Yeah, so we're using Opus 4.6 Max to pull the container. So it's basically doing the pull right now, downloading checksum. I don't know how long this is going to take. We'll see. Perfect. Awesome. 5 a.m. in Spain. Good morning. Thank you so much for tuning in, man. This is wild. Oh, by the way, just to give you guys a heads up, I turned off the monetization on this live stream, and I've been doing this on the encouragement of my friend Alex Finn. So he says like he turns off monetization, and I think that's a really good idea because it just allows us to kind of hang out together without any interruptions. I think the second part of it is that anyone who is, like a person who's paying for ads, they pretty much just take over the whole thing. I saw that they take over all these different spaces, and I don't always endorse those types of things. And I feel like this whole live stream is really supported from viewers like you. So people who like pay for the memberships, people who pay for the Discord stuff, that helps kind of fuel everything. It helps me like go to events. I'm planning to do some more meetups and stuff, but you also get different perks depending on the different levels that you support. Also, if you're just even watching for free, the fact that you're here watching, liking, and sharing it with someone else actually makes it go a long way. So depending on where you're at, there's a lot of information available, and hopefully it's helping you out as well. And so I definitely appreciate anyone who's been able to engage, share, drop comments and stuff. This has been really, really helpful. Like from thumbs up and all these different things actually do go a long way, and it gives signal to YouTube that, hey, you're actually interested in this stuff. So I just wanted to let you know that, just being like, super awesome about this. I also want to be transparent that, NVIDIA did send me the Spark a while back, and I've been trying to find a really good use case for this. And OpenClaw, with my research, I've been using OpenClaw a lot. And with my memory stuff, I'm like really interested. I was like, oh, I really want this to work so much. And so I have no clue whether this is going to work or not. They don't have any input as far as like what stuff I should talk about or anything like that. I have free form. I could do whatever I want. And so I'm using this opportunity because I have this device. I don't yet have a Mac Studio. So this is going to be, my foray into trying to play around with this stuff. Low key, I've been wanting to become like, to learn how to program the GPUs actually. I have a background, working on low level hardware at Apple, and all the way up into the operating system and to other types of systems as well. And so, robotics are really interesting with me, and this is something that I'm going to continue to like scratch my itch on. And I feel like the Spark is kind of like the first gateway drug in. In a funny way. So we're going to explore. Y'all going to chill with me right now. And then I'm going to try to see if I can fix my tint and colors, by the way. So that way we can kind of do this type of thing. So yeah, I really appreciate everyone who's kind of locking in with me right now, and we're kind of hanging out. So let's go ahead and see how we're doing with our latest Docker progress. We're just pulling everything here. Oh yeah, 2026 is amazing if you have a job. Could I work with you? I'm doing well, finished big things. What type of stuff do you want to do, man? Do you vibe code? Let's vibe code. Okay, so what do we do? Okay, the image downloaded, and now we're basically going to hand this off to, okay, model not cached yet. So now it's pulling the model, right? Okay, so Docker run. I love that things are just kind of going autonomously. This is so nice. This is probably my favorite part. Yeah, let me know what you want to do. I'm currently setting up a solid memory system on a solid layer, not for my setup. QMD is really basic, and yeah, and still require the agents to write stuff down, which they're not great at sometimes. That's kind of why I'm starting to move into different system revenue pulse, and this is a big reason why I wanted to explore the landscape of the Spark. And even just local hardware, right? Because this can also apply to your Mac. And anyone who's interested, you can take screenshots or just transcribe this entire live stream and say, I want to run this on the Mac. How can we explore that space? And this is kind of what I'm doing. And you'll start to kind of get similar research because these models are really smart. So yeah, Revenant Post, let me know what you learned. I'm really curious. MemZero install Llama locally has been the best memory move, I bet. Oh, interesting. Let's take a look. MemZero. Is it MemZero AI? Does it cost? Set it up in 60 seconds. Is this an ad, bro? Did you? I know these guys. Oh, wow. Yeah, like these, I put on, like, they got 1 million views. Check this out. When they went to the Grok meetup, these guys are my favorite. Open note. We got like 1 million views. Let's see. Uh, Here we go. Let me go back to the very top. I posted it on my account and they got 1 million views, and that's all they got. Like all these investors and everyone hitting them up. Like I saw them, I talked to them at the Grok meetup. I was like, bro, how do you have 17K users and like where's your investors? They're like, oh, we haven't raised yet. We need to raise. And I was like, let me just make a post on X for you guys because I really like what you guys are doing. And I basically said, I made a call to action. I was like, yo, investors need to pull up. Like these kids are are like just cooking. And so, yeah, I mean, they're still in college and stuff, and they did raise after that. I mean, they had so many DMs, they just couldn't really handle it. But yeah, this got 1 million views. And I love the work that they're doing. They're super smart. It's funny because they don't even code with AI. They actually teach a lot of kids coding and stuff like that. And they actually made this app because that's actually was helping they were actually tutoring other kids. So these kids are super smart. I want to read their case study. Wow. Track each student's struggles, strengths, and learning style across the entire platform and tools. Damn. Okay. The challenge bringing continuity to open-ended learning flow. I should hit them up. I actually, I should interview them and have them like teach me about memory. Wow. We're incredibly glad to be working with this team. Into Feynman too. Yeah, they have their own model too for training. This is fire, bro. So OpenNote over so the metric they use was token usage per prompt. The full history included, after summarize relevant memory, 40% reduction. The session continuity, stateless, repetitive, increased engagement, fast implementation, and it created in 2 days. Feels personalized. Okay, let me go back to products, MemZero. Is it open sourced? Okay. Pricing? Bruh. Y'all know I got like infinite memories, bro. Why is it so expensive? Can't we just do this locally ourselves? We have AI, right? Damn, son. Open memory? Make agents code your way? Bro, no way, bro. That's crazy. Huh. That's interesting. If this works, I need to start charging a bag. You know what I mean? I mean, y'all getting this for free. Yeah, at least you could do is like give the like and thumbs up, bro. No way. Oh man. Do you have a Claude directory and an OpenClaw one? It's symlinks. Claude Code told me that's why my OpenClaw was so stupid. Oh. I don't. But yeah, that's probably why your problem is. Yeah. For those who don't know, if you run like Claude Code or something in the directory and tell it to fix your OpenClaw instance, it will definitely fix it. Because whenever people are having problems. All right, so we're basically now just downloading the model on my Spark, and so that's what it's doing right now. So it's just fetching all the files. So we're just kind of waiting for that to kind of happen here. So while we're waiting, we're just kind of interacting with the chat. We have YouTube Premium over here. Free version is for the permanent. Respectfully, bro. Respectfully. Bro, I like how you added the respectfully. We have YouTube Premium over here. The free versions for the underclass. Bruh, are you sipping on matchas too? You got the quarter zips? You're part of the movement, bro. All I want is Trismith's open jaw. No, wait. Okay. 2026 amazing. Okay. Yeah, I'm a little late right now. Is that the 4-bit precision on that 30-bit? Yeah. Do you see the difference when the weights are less precise? So I think this is actually supposed to be tuned specifically for the NVFE4, and I'm really curious to see how much this comes out. Xavier, so I would spend 200 bucks a month on the Ultra plan plus 40 bucks on the bug bot. And I would typically go through the limits within 15 to 25 days, depending on what I was doing. And what I had to do to optimize my spending was to go through and use the plan mode a lot. So a lot of times I had no clue what I was doing in my code, so I would just plan to get an understanding. And then once I started shipping features, I would just started, getting more familiar with the code base. And then when I shipped new features, I would either start to like pull in the files that I needed or, like start in plan mode, say, I have no clue what to do with this feature. What should we do? And just have that conversation back and forth. Getting that clarity is very, very helpful. And it does save me lots of tokens. I also had a challenge in December to ship an entire game multiplayer in 12 days before Christmas because that's what I wanted to do before my limit was used. And so I was able to ship the entire game in like less than $200 of credits. So like, or not credits, less than $200 in the $200 a month plan. So it turns out that the plan gives you like $400 in credits, which is super useful. And I didn't even use all $400. I used like 250 or something like that. So yeah, I was able to, it's kind of nice what they do, but this was before they dropped like Opus 4.6, before all the like, I think GPT 5.2 just came out, but they didn't have the new composer model yet. Like the new composer model is fire. I'd probably be using that all the time. Kimi K2 wasn't out. So like there's a whole bunch of other stuff that hasn't come out. So now these plans can go a lot longer. And as far as a harness, it's greatly improved as we saw from using it. And they've continued to improve a lot. And in addition to that, the Cursor team reached out and they said, hey, we have a whole bunch of stuff that's coming in the pipeline. We'd love to like basically get you some research credits so that you can just do whatever you want. And I'm like, are you kidding me right now? Like, this is crazy. So that's basically what ended up happening is that like now I have basically some research credits and I was like, so Opus Fast came out, 4.6. How much can I just burn through like $1,000 worth of credits? They're just like, yeah, but I wouldn't encourage you to use it every day. I was like, okay. I was like, okay, but like I can kind of let it rip if you know what I mean. So that's been really, really cool. And so yeah, basically as of this like last month or so, I have been using some of these research credits, which has been super handy. And I would encourage you to, yeah, definitely use plan mode if you're burning through credits pretty fast. Try other models like Codex is amazing. GPT 5.3 Codex is amazing for conversations. And it's actually pretty fast on this because you can tell Cursor to use parallel agents with Codex and it'll just start to rip through your code base super fast. And it's fairly, cost effective too. So, and then the new Codex just by itself, just by launching into CLI is also really good too. Everyone's like, there's so much like improvements in these models. So I really do appreciate like the OpenAI team and everyone who's really just kind of shipping like crazy to make everything work really well. But I didn't finish because HTC. Okay. I'm super interested in this type of data storage retrieval. Going to be a fun project to follow along. Yeah, I would encourage you to build along with me because I want you to share whatever you learn with everyone else. MemZero has a local option and I'd love to switch from QMD. Yeah, interesting. I got to look into that. I disagree on MemZero, hugely bad experience, but maybe it's improved. When I tried it, it was terrible, barely worked, no help in Discord. Oof, okay. It's free. Check this out. Okay. If you want to work with GPUs and LMs desperately need a vibe check, okay. You should definitely try MemZero bin at last. Bin at last. Okay. MemZero open source? User session. Okay. Okay, Claude. Let's see. Can you look through my previous chats about memory with OpenClaw and my plan? How that compares to using MemZero? Use Exa and ref tools MCP. Okay, let's just do some research while this is going. Personalized chat powered by MemZero, browser extension, CreAI. Legit. Okay, okay. Founder of Firesides. Memory in the age of AI agents. There's a paper too? Retrieval problem. Memory is governed by three operators. Formation, which decides what gets written. Evolution, which determines how memory is consolidated, rewritten, and discarded. Retrieval, which decides what gets surfaced back to the model at the decision time. Many existing agent memory systems place most of their emphasis on retrieval and rely heavily on static recall mechanisms. Without meaningful evolution, memory keeps growing, due to which redundant entries accumulate and conflicts remain unsolved. The result is often growing record of past interactions rather than a curated list of adaptive memory base. One of the more subtle points of the paper is how it treats short-term versus long-term memory. These are not presented as separate architectural components. Instead, temporal roles emerge from how frequently formation, evolution, and retrieval are invoked. If information happens frequently while evolution is rarely applied, the agent becomes verbose but brittle. If the evolution is overly aggressive, stability can break down. So the direction is not simply better retrieval, it's the design of memory evolution policies that decide when the experience should be compressed, merged, rewritten. And this is where memory moves back beyond storage and begins to take shape agent behavior over time. So I should just probably pop this paper into my Opus research. This looks fire. And have it study this. Memory in the age of AI agents. Survey, forms, functions, dynamics. Bruh, please. Okay. Oh my God. Okay, let's see what's going on over here. Let me pull up our past conversations. Okay. No, this is not it. I think I'm gonna go back over here. I think it's under my projects for this guy. Oops. It's under this one. Okay. And let's see if I can give it this screenshot. Whoops. RVX paper. Also pull up this RVX paper. We will rebuild. Also pull up the paper in the screenshot or research. Okay. Cook, my friend, cook. Okay, cool. Do you have a Claude directory? Okay, sorry for asking so many times. What does it say? And oh, I think you already fixed this, right? MemZero is a recursive learning abstraction layer, mostly easy to implement locally if the up-to-date on publications. Okay, that's interesting. That's cool that we could even do that. Originally, GLM5 told me it was fine. Cloud Code told me it was not good. Okay, I think you're debugging your thing. YouTube Premium is the best sub ever. We'll have another project that has neuromorphic design and is a memory system that's based on hippocampus. It's currently translating endpoints so I can drop into OpenClaw. Okay, that's right, quarters of something. Okay, I got 2 Sparks waiting on my cable. Oh, bro, the delay in the cables are killer, bro. Is yours coming in March? I'm curious, Phil. Yeah, I really appreciate I appreciate and fully support running AI tools locally. However, I wouldn't dismiss hosted solutions for all users. I agree. Time plus hardware, electric bill stack up, worth it. Yeah, that's why I'm trying to experiment on the Spark and also experiment on with local models. For me, it's going to be more about the learning journey because I want to understand and speak about memory systems. Like, no one really understands this space yet because all these people from MemZero to super memory to all these folks have different use cases. And that just means that the field is wide open, right? So there's call center type of stuff, there's meeting notes, there's, I mean, a lot of different people who have law, like who are interviewing clients. There's different use cases and different things that will be sufficient. And I don't even know the landscape enough to say, you know, this specific stack will work for you or you need these baseline things. And the models can help guide us to different use cases, and I'm going to learn with my own data sets. And so I'm using OpenClaw, as one part of it, but I have a lot of other stuff that's coming in. And so for those folks who are just joining in right now, I'm going to give you a quick overview of kind of what this looks like and what we're trying to achieve. And so what we're doing is we have our first layer of data, which is audio, transcriptions, Notion documents, Slack messages, markdown files, Google Workspace, and so forth. Our second layer is basically going to try to understand it. So we have that going to be going to these two different things, the NV embed v2, which is going to convert the text into like these meaning vectors for search. And that's going to go over to Qwen for the database. And then we haveGlinear, which basically finds people, projects, and then tags those types of things with people's decisions and processes the data. And that's going to be done with FalkerDB. So that's going to do the relationship mapping. So that's what people are talking about there. And then we're going to use the Qwen model to basically reason over these and figure out, what's going to do stuff. And that's going to be all done locally. I'm hoping to learn a lot here and kind of basically battle test this stuff locally. And then I should be able to change out different models or reindex and try different things here. Because this is based off of a lot of research that I was doing earlier on like what specific stack I should be working with to try to achieve this. This was inspired from this company called Pulse HQ. So they made a video on YouTube and I was basically studying it, in which they basically were taking conversations, tickets, and all this different stuff from actual data centers, from the call centers. And they were basically doing this ingestion pipeline and this agentic flow all on a Spark, all locally and stuff, which is crazy. So when people join a call in real time, they're able to extract all this stuff about the customer and make all these cool decisions. So I did some more research and try to figure out what models would apply on the Spark for these types of use cases, and it did a whole breakdown for me. You can try to do the same thing with whatever hardware you have, and it should give you a breakdown here. And this is kind of how we ended up at some of these types of models here. So we should be able to change stuff out and see, what parameters we need to tune, from temperature to context length to, whatever stuff we need to do for, understanding how we can kind of make this stuff happen. So this is an exciting project because we should be able to use quite a bit of memory here and not overload it. But, if I'm able to do this type of processing locally, it's going to save like 400 to 500 bucks a month easily because these guys charge a lot of money for this stuff. But then I'll learn a lot more at the end of this other side of this whole thing. Is like, I'll know more about these types of systems and be able to actually speak on them, because very few people know so much of these different stacks, and they're really hard to do. So what's going on here? So the paper argues that the traditional short-term dichotomy is insufficient and proposes forms, functions, dynamics framework instead. So by that measure, OpenClaw is mostly operating in the simplest quadrant. So flat token level, manually created factual memory with basic retrieval, while MemZero spans more of a space but still doesn't touch the parametric memory, which is fine tuning, or latent memory transformations. So the bottom line for your Spark setup, if you're building agents that need persistent memory, MemZero is more capable foundation, especially since you can use GLM 4.7 Flash, and this is the extraction LLM, and everything runs locally. OpenClaw's markdown approach is great for transparency and simplicity, but it doesn't scale well for complex agent workflows. The hybrid play that some people are already doing is OpenClaw Omega or OpenClaw plus MemZero MCP plugin, which might be the most practical path if you want OpenClaw's agent framework. Okay, that's interesting. I don't know. John, 3 memory scopes. Wait, don't we have that already with, let's see. Contextual memory. Wait, don't we have? So what are we doing then with? Let's see. Let's see here. And what is our solution better? What are the trade-offs? Okay, gonna have a look. Okay. Yeah, that's X. Okay. So yeah, that's what we're doing here. Let's see how this is going over here on Cursor Land. We're done. Okay, cool. Awesome. Okay. Let's see. So we've downloaded everything. Damn. So Docker stop. Okay. The ARG entry is overriding your args based on the defaults. Let me bypass the entry point by calling vLLM directly. Looks excellent. Our args have been respected now. Critically using the flash infer cutlass for MVFP4 is working now. So the model loading is in progress. Let me wait for it to finish. Sweet. Okay, so the model loaded is 16 gigabytes. CUDA graph compiled, KV cache configured. Let's go. 13x concurrency at 32K, flash inference warming up. Almost there. Let me wait for CUDA graph catcher and the server to start up. So the model is currently serving Qwen 30B reasoning. So now let me test the inference. The inference is working. The model uses thinking tokens. So it ran out of tokens at 10. Let me pull the full phase 2 verification with enough tokens in the knowledge graph test. Wow. Okay, so attempt A succeeded, so no fallback needed. So here's the summary. So now we have the Avarak vLLM DGX Spark latest with the Qwen 3 30B reasoning on port here. And now we have this here. So the throughput is 60 tokens per second. So that's 300 tokens in 5 seconds, including thinking. And the system memory used is 49 gigabytes. So the reasoning model is generating coherent responses with think, chain of thought, plenty of headroom left for the remaining services. Ready for phase 3, which is Whisper whenever you are. Whoa, this is cool. So phase 2 was basically just trying to get the vLLM model set up with the Qwen, right? So Qwen 3 30 billion. Nice. Okay. And then we have the Avarak image. Cool. And so we don't have to do the fallback. And we verified that Qwen 3 works. Perfect. And so perfect. So now we're going to move on to phase 3, which is going to be WhisperX with diarization. So we're going to set up the GPU accelerated speech to text with the speaker identification, because meeting transcriptions also involve like who said what. And this is going to be what it downloads here. So we're going to pull WhisperX, and we're going to have, I don't know if I have a Hugging Face token, but I'll have to get one and then verify this stuff here. So, okay, cool. That's awesome. Yeah, let me catch up a little bit with the comments here. Let's see. Yeah, MVFP4 is designed for this actual Spark. Yeah, this is amazing. I like telling OpenClaw my agent to use open code with Codex, and it works really well. Yeah, that's a really good idea, and also saves you on token costs too. So yeah, thanks. Gonna get a part-time job and set up cursor credits to run local models. My goal is to run a decent coding model locally. Yeah, cool. Search recursive learning models for persistent memory. This might be worthwhile to learn with local LLMs. Dude, we gotta update your username, man, because you're the MVP of the chat right now, Claude. Okay, so what am I doing here? Whoa, 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 whoa. Should we get the contextual memory? Let me send this across. Oops. I told him this is okay. My agent suggested setting up MemZero with Olama. Oh, okay. Interesting. With MemZero, are you uploading your data to the servers or fewer? I'm gonna try to keep everything locally. Yeah, I don't want to upload this stuff to the server. Don't give Claude the paper. It can give you the correct one. Okay. Oh yeah, so I heard about timescale DB as well, QuestDB. Yeah, because so the timescale stuff, it's also really important to know, what happened where, like time-wise. Hey, tech friend, how's it going, man? Appreciate you being on the stream here. It was just Claude's Code's first birthday. Oh, cool. Did you go to the event? How did you come up with the organization for the Racer board? I have a cursor prompt that I did. I gave it the whole research paper and I said, I'm using a Racer. Help me set up the stuff. Hey, Roman, how's it going? Still human, boss. Okay, cool. Thanks for reposting the stream. Oh, so did you find out what's going on about OpenClaw, like behind the scenes, like the wink, wink, aspect of it? Would love to know. I'm vectorizing everything. So like everything, like literally not vectorizing, but I'm basically building this whole memory layer here. So everything is going to go through here. It's going to go through layer 2, and this is how it's going to be split out for the understanding for these types of prompts. And then we're going to basically reason over it here. So I have Scott. I also have the stuff if you're in the Discord for you to check out. You can check out these links, and I also have all the research here that's available for like the how we kind of went through all these models and kind of came to this decision as well. So I have two different links for the research. So this is the research stuff, which goes even in more depth for those who are wondering like what the architecture is like, how I set up my VPN tunneling, to like the data flow for the auto processing and like the different services and where they're hit, to the actual like the RAG sequences too for how the user will make a request with semantic search and stuff. And then we also have like the execution order that's mapped out. So I have everything all mapped out here, even the network topology map with the different port numbers, because there's a lot of stuff going on. But yeah, all of this stuff was prompted, which is amazing. So yeah, you banned my other accounts despite complementing OpenClaw for reducing. I might have banned it because it may have been through like what do you call it? A lot of times I'm basically just auto banning people who are using OpenClaw and doing AI slop, because it's really hard to tell sometimes, you know, what a user is real or not, or if they user actually inserts, you know, the AI slop stuff. So like would love to know what your account name is so I can take a look at the account and see what happened to go through that. So yeah. Okay, cool. Yeah, I think that's like some of the people's like say certain things on X. Like I'll show you right now. It's so annoying. Yeah. Like I'll go to my profile. There's a couple. So like this kind of looks like this is actually insane for productivity workflows. How's the latency? Like they always ask a question afterwards. Like this is a common LinkedIn AI bot response. Like I'll post something and they'll take something in here and try to like ask a question for engagement, like to try to engage back. And it's like, yeah, it's typical like bot behavior. Like it just shows up all the time. So let's see what's going on. Like, this is kind of bot like. I've been wondering, has been getting more love from the OpenClaw community. Yeah, this is real interesting. Graph size impacts retrieval latency, especially with complex relationships. Experiment with different embedding strategies and graph. Like this says nothing, right? Like this is totally bot, you know? You know, it's like, oh my God. Yeah, I just can't do that. Yeah, like it's getting really out of hand and it's kind of annoying. Like people who just use bots all the time. So yeah, let's see. Yeah. So I don't know, like if I think it's a bot or if you are using a bot, then you're probably gonna get banned. Yeah. Yeah, no, I'm saying like if the previous account that he was using was basically, I thought it was like a bot reply or something like that, then I just banned it because there's just like the chat was going really crazy. And then the other thing too is if I do IRL streams, I can't moderate. So that's also what happens too. So yeah. Number something stated OpenClaw engineering prompt injection skills, not substantially more. However, their ability to mitigate market extensions press component. Half of X is bots now, I'm convinced. Yeah, it feels that way for sure. Let's see. Okay, so we are doing some research here. So this is a gold mine, right? There's actually several distinct but related concepts here that they're all converging in a way that's very relevant to what you're building with Spark. So the RLMs, oh, okay, so I remember hearing about this. Are Alex saying Tim Karsa, Omar Khattab. So the core idea is elegant. Instead of stuffing your entire context into LLM's attention window where there's rots, you treat the context as a variable in Python REPL environment, and LLM writes code to programmatically examine, decompose, and recursively call itself on smaller submodules over chunks of that context. Yeah, so in essence, you're fanning out everything, and then you're then probably going to do some type of reasoning over that. Yeah. So yeah, that makes sense because the training is different. Yeah, you're doing two different approaches. Why this matters for the Spark official RLM library? Cool. Oh, this is fire, bro. Oh, huh. So so there's a knowledge crystallization published literally today, bro. Bro, like the comments right here are crazy, bro. Are we sure we're not all bots? Yeah. We're all hosted on DGX Spark. Yeah. So an agent iteratively records and refines operational knowledge. Okay. I can message you from my main account. Recently finished my Series B fundraising work daily with architecting layers of Gen AI. Are you on X, bro? Hit me, slide in my DMs. Let me know what your account is. Yeah. Because you've been dropping so much sauce, bro. It reinforces learning to distill raw agent trajectories, skill bank library, and adaptive retrieval strategy. Okay. So here's all of this maps against what we discussed earlier. Stop it. Stop it, bro. Stop. If you're not on X, bro, you're cooked. How much money per year do you make using AI? I make $0, actually negative. Right now, like negative $100,000 a year. RLMs, okay. Let's see. Yeah, if you're in here to like get rich quick, like this is not your show. Like right here, we're basically engineers, and I'm an engineer and I'm trying to learn what this technology is. How can I use it to solve my own use cases? Because I have a business that I'm running, and like I have to literally do stuff by hand. I listen to stuff on X, I listen to podcasts, and I don't know what people are really saying because I haven't had hands-on experience. That's how I learned growing up. That's how I learned when I worked at Apple. I basically learned by doing. By doing that, I actually got to learn within 1 year so much more than many engineers who'd been there for 10 plus years, because I actually got my hands dirty. I did debugging in the kernel. I did debugging at low levels. I brought attention to all kinds of crazy bugs. I got to learn how systems really worked. I built my own tools. I built everything. And that's kind of how I got to understand the systems better than the engineers who even wrote the systems, because they're sometimes so narrowly focused on one single component, but then never look at it like holistically as far as how the system comes together. And there are differences when you start to put these systems together and they start to play around in the real world. There's new things that pop up, and that's part of my strength. And if you're here to say like, I'm only here to watch this guy, like see if he can make, $1 million for whatever. There's like a lot of those types of content that you can go watch, and YouTube's full of them. And so please leave this stream. This is for people who are like super serious trying to learn and trying to improve themselves, but also like take on that challenge for themselves. Like for me, I enjoy this challenge of trying to like learn about how memory works. I'm not an ML engineer, so we're going to basically learn this on the fly. And whatever I learn, I'm sharing back with you. So OpenClaw is a great gateway drug because everyone's using it right now, and it's a good exercise of handling all these different plugins, all these different environment variables, things that can come in, and then you couple that with hardware, which makes it really, really cool. So this is what we're all about here. We're here to like really build together, like build community with other people who are kind of like-minded, and we're not here to like get rich quick. And if you want to do that, there's tons of content for you on YouTube. So that's what's up. I'm trying to get rich quick. Yeah. I've been in my room 18 hours a day vibe coding. Yeah. Making money is easy. Gaining knowledge is difficult. Yeah. Learning Cloud Agent SDK is excellent for understanding how, yep. Look, yeah. Cool. All right. So I'm going to take a look at this, and I need to go head out and get some dinner right now. And I will see you guys tomorrow. I'll be continuing this stream because we have a whole bunch more stuff to do to get all of the different models set up. So that way we can have this really like amazing memory, and going to test this out and kind of tell you what I learned. So if you haven't had a chance, make sure you like, subscribe. I appreciate everyone who's been able to support the channel through the Discord memberships. If you go check out the pinned link here down below. Also, if you anyone who subscribes and become members, super awesome. This whole stream is supported by viewers like you because this stream is currently not running any ads. I've turned off monetization just so that we can hang out together and enjoy this together. So you don't have to have YouTube Premium, but I appreciate everyone who's been able to stop by and support it in any single way. And hopefully you're taking on a challenge like this to build for yourself so you can make yourself better. And I will see you guys tomorrow. Peace out, y'all. Aloha and mahalo. Yeah. Let's see. Big shout outs to Augment OS as well for hanging out here. AJ as well. Data Mental Machine. Who else is up in here? A Starship. Oh, Gabriel, how's it going? User, yeah, J35, IDAN, Javier. Let's see, everyone who's just Spark Spectrum 521, J35 Vibin, Augment OS. Yeah, thank you guys so much for participating. I really appreciate y'all.